All right, so I'm hoping Section 8.5 is a nice and not too long section. It's on systems of nonlinear equations, and in Section 8.1, we did systems of linear equations. To be nonlinear, at least one of the equations needs to have an exponent for a letter, and that would make the graph not a line, so it wouldn't be a nonlinear equation. You can't use matrices to solve systems of nonlinear equations. Matrices are used to solve systems of linear equations and not nonlinear equations. So we won't be able to use matrices in this section because of the exponents on the letters. In Section 8.1, we learned how to solve systems of equations using both the elimination method and the substitution method. These problems really don't lend themselves very nicely to the elimination method. Matrices, we did all elimination method, and in Section 8.1, we did combination of substitution and elimination method. These problems are best solved using substitution, and it's the rare student that can get the answer to these problems correctly using the elimination method, and it's just not good for these kinds of problems. So for every problem in this section, I'm going to solve using the substitution method, and I won't use the elimination method at all. There's a few of the problems that might be able to be solved using the elimination method, but students are tempted to combine terms, add or subtract terms that don't have the same exponents when they try to use elimination methods in this section, so don't try it. Matrices definitely won't work because these aren't linear equations. They're nonlinear because at least one of the equations has an exponent for at least one of the letters. So to do the substitution method, in case you don't remember a few sections ago, we need to pick an equation, and pick a letter to solve for. I'm pretty sure on the test I suggest what equation to do, but don't hold me to that right now because it's been a while since I've written a test for Chapter 8. Probably the best thing for you to do is when you're doing problem 1, pick the top equation and solve it for y, and I'll do the same. I'm going to pick the top equation and solve for y. So my first step, pick the top equation, and solve for y. So that's easy enough. The top equation says x plus y equal to 0. I'll just minus x from both sides and get y equal to negative x. So that's the first part of my substitution method. The second is to substitute into the unused equation. So substitute into the other equation. And then solve that equation. So I'm going to change in this equation, I'm going to change that y to a negative x because y equals negative x where these two equations intersect in some sense. So I'm going to write the second equation as x cubed minus 5x and then minus and then negative x and then equal to 0. So all I've done is change that y to a negative x. I've produced a double negative. When I produce a double negative, I should probably put it in a parentheses. I'm going to change that double negative to positive. This is going to give me x cubed minus 5x plus x equals to 0. And this plus x is really plus 1x. I'm going to combine like terms. Because I have an exponent, it's appropriate to solve by factoring and have one side 0. So this is going to take me to x cubed minus 4x equals to 0, because that's what you get when you combine the minus 5x and the positive 1x. And now I'm going to solve by factoring. I'm going to pull out a common factor of an x. And that's going to leave me with x squared minus 4. And the x squared minus 4 I can factor into x plus 2 times x minus 2. Now I have 3 factors. I'm going to set each of them equal to 0. I'll set x equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. When I set x plus 2 equal to 0, I get x equal to negative 2. When I set x minus 2 equal to 0, I get x equal to 2. And when I set x equal to 0, I get x equal to 0. So first I picked an equation, picked the top equation, solved it for y. Second, I substituted into the other equation and solved that equation. That's what I did second. Third, in this particular problem, you're going to pair your solutions, which means if you have an x, you need to get a corresponding y. If you have a y, you're going to get a corresponding x. So I'm going to pair each solution with the other letter. And how am I going to do that? I'm going to use this with my answers. So for my x equal to 0, I'm going to use y equal to negative x. And I'm going to substitute 0 in. I'm going to get y equals negative 0. That means negative 1 times 0, and that's just 0. My calculator, if I entered negative 0, it's going to tell me that that equals to 0. So this gives me y equal to 0. And this is going to give a solution. The solution is x equal to 0, y equal to 0. For the next x equal to negative 2, I'm going to go y equals negative x. And I'm going to plug negative 2 in for x. I'll get y equals negative 2, double negative, so I did a parentheses. This will give me y equal to 2. This is going to give me a solution, x equal to negative 2, y equal to 2. And lastly, when x equal to 2, I'll use y equal to negative x. And this x equal to 2, I'll go y equals negative from that formula, 2 for the x. That's already solved. That gives me the solution 2, negative 2. This is apparently my answer to problem 2. My instructions say be sure to check your answers. It's kind of a nuisance, but I will check each one, at least on this first problem. So I'll show you how to check. So my initial system of equations says x plus y equal to 0 and x cubed minus 5x minus y equal to 0. Let me check the 0, 0 first, and then I'll check the negative 2, 2, and then the 2, negative 2. So to check 0, 0, for each x and each y in the top equation, I need to plug 0 in. And in the bottom equation, I need to plug 0 in for the x's and the y's. This top one is clearly comes out to 0 equal to 0, so it checks there because it gives me a true statement. And the bottom one, to me, is kind of clear that this is 0 minus 0 minus 0 equal to 0, and that gives me 0 equal to 0. So it checks there as well. So that solution checks just fine. Now I'm going to check the negative 2, 2 by putting negative 2 and positive 2 in for the x and y in the top equation. I'll make this top equation negative 2 plus 2 equal to 0. That simplifies to 0 equal to 0, so it checks there. In the bottom equation, I'm going to go negative 2 cubed, plugging negative 2 in for that x, minus 5 times negative 2, plugging negative 2 in for that x, and then minus, and then plugging 2 in for that y, equals to 0. That I'm going to check on my calculator. So on my calculator, this better equal to 0. I'm going to go parentheses, negative 2, up arrow 3, minus 5, parentheses, negative 2, minus 2. And because it equals 0, I can put a little check next to that. So I've checked 2 of my 3 solutions. The last solution to check is the 2, negative 2. Now I'm going to plug them both into each of these equations. So for the first one, top equation, I'm going to plug 2 for x, and then the plus sign, and then negative 2 for y. And that clearly simplifies to 0. And then for the bottom one, I'm going to plug 2 in for that x, minus 5, 2 in for that x, minus, and then negative 2 for that y, and then it has to equal to 0. Do that on my calculator again, so clear parentheses 2 cubed minus 5 parentheses 2 minus parentheses negative 2. If when I hit enter it says 0, I know my answer is correct because the right side is 0. If when I hit enter I don't get 0, my answer is wrong. And it actually checks just fine. So checking is just a matter of taking any one of your answers, plugging it into both, separately into both equations, and making sure you get true statements. Your problem 1 should solve a lot like my number 2, in that you're going to need a common factor to get your x solved for. Three and 4 are a little bit messier, but I think we only get 2 solutions. For your problem 3 and my problem 4, on my first step, I'm going to solve the top equation for y. And that's what you should do on number 3. So my top equation is 3x plus y equal to 5. I'm going to minus 3x from both sides and get y equal to minus 3x plus 5. For step 2, I'm going to substitute into the bottom equation and solve. It's going to give me kind of 2 answers, and I'll have to pair each answer with the other letter. So I'm going to substitute in for this x, or in for this y, a negative 3x plus 5. So I'm going to write x squared plus parentheses negative 3x plus 5 squared equals to 5. And now I need to solve this by clearing the parentheses that I imposed, and this is best cleared by writing it without the exponent. So I'm going to rewrite that parentheses so it doesn't have that exponent. Now I'm going to FOIL. I'm going to go leave this x squared, do my first, our negative 3x times negative 3x, which is plus 9x squared. My outers are negative 3x times 5, which is negative 15x. My inners are 5 times negative 3x, which is negative 15x. My lasts are 5 times 5, which is positive 25, equals 5. All right. Now I'm going to combine like terms on the left side. The first terms are really 1x squared plus 9x squared, which are 10x squared. The 15x's combined, they don't cancel because they have the same sign. I add the numbers in front and keep them negative. And to save some room, I'm going to get this equal to 0 by minusing 5 from both sides on this step. So I'm combining like terms, and I'm going to minus 5 from both sides. That's going to make this a plus 20, and on the right side I'll have an equal to 0. There's a common factor in a problem that has an equal sign that doesn't have a letter. probably slickest to divide that common factor away. So I'm going to divide the common factor away. And this, you can only divide out a common factor if it doesn't have a letter and when the problem has an equal sign. And if the problem has an equal sign and you have a common factor that doesn't have a letter, that's probably the nicest thing to do just to get the problem solvable. So I divided out that nasty common factor, and I have something that's a lot easier to solve. I can factor this. If you can't factor this, pull out the quadratic formula. This factors into x minus 1 times x minus 2. So now I'm at the point where I can go x minus 1 equal to 0, which is going to give me x equal to 1, and x minus 2 equal to 0, which is going to give me x equal to 2. Done with step 2, on to step 3 is going to pair, get the opposite letter. So step 3, in this case I'm going to get a y for each x. And I'm going to use this equation, y equals negative 3x plus 5. So I'm going to use y equals negative 3x plus 5. And for x equal to 1, I'm going to get y equals negative 3 times 1 plus 5. It's going to be y equals negative 3 plus 5, which is going to be y equal to 2. That's going to be part of my answer. I used x equal to 1 and got y equal to 2. Now for x equal to 2, I'm going to go y equals negative 3 times 2 plus 5, just plugging my x into that formula. It's going to give me y equal to negative 6 plus 5. It's going to give me y equal to negative 1. As an answer, it's going to be x equal to 2, y equal to negative 1. Done with the problem, but I haven't checked. So to check this, I'm going to use the system of equations 3x plus y equal to 5 and x squared plus y squared equal to 5. So I'm going to do each one just kind of off to the side. So for the point 1, 2 in this first equation has to be 3 times 1 plus 2 equals to 5. That's going to give me 3 plus 2 equal to 5, which is 5 equal to 5. And in the bottom one, it's going to be 1 for x squared plus 2 for y squared equals to 5. It's going to give me 1 plus 4 equal to 5, or 5 equal to 5. For the second one, I'm going to plug 2 in for x, negative 1 in for y. This is going to give me 6 plus negative 1 equal to 5 in the top equation, which is 5 equal to 5. In the bottom equation, I'm going to plug in 2 for x, negative 1 for y. It's going to give me 4 plus 1 equal to 5, or 5 equal to 5. The checking is optional for these problems, but it's not particularly hard to do, and you can be guaranteed that your answer is correct if you take the time to check and you get all trueness. You're going to have, for each solution, you have to check into both equations. So there's a lot of checking that needs to be done. So your problem 3, you should do similarly. Solve the top equation for y, substitute it into the bottom equation, make sure you FOIL when you get rid of that exponent. You'll probably have a common factor that has a number that you can divide away. And then once you actually get the answers for x, you're going to have to finish it up by getting a y for each x. And then if you want to check, check. For your problem 5, you should solve the top equation for y on your first step, because the y is easy to solve for. But for me, if I solved my top equation for y, the y has a square. It's not so easy to solve for. I'm going to, on my first step, so this would be for number 5, but I'm doing number 6. And on my number 6, I'm going to do for my step 1, I'm going to solve the top equation for x. Super easy to do. I have x plus y squared equal to 0. This is going to give me x equals negative y squared if you minus y squared from both sides. Now for my step 2, I'm going to substitute and solve. Notice I'm not using the elimination method at all in this section. It's not good for this section. So for this x right there, I'm going to put a negative y squared. So I'm going to go y cubed minus 5 times negative y squared minus 6y equals to 0. I have a double negative here that I'm going to change to positive. I'm going to write this as y cubed plus 5y squared minus 6y equals to 0. I'm going to solve this by factoring. I'm going to pull out a common factor of a y. Your problem's going to solve a little bit differently. Maybe I'll do it. But I'm going to pull out a common factor of a y and get y times y squared plus 5y minus 6 equals to 0. And then factor what's left in the parentheses into y plus 6 times y minus 1. Now set each of the factors equal to 0. The first one you get y equal to 0. The middle one you get y equal to negative 6. The third one you get y equal to 1. And it's a little bit tricky here on my substituting. I have x equals to negative y squared. It's probably going to help you to think of this as x equals to negative 1y squared when you substitute. So for each y, I need to get an x. For this first one, I'm going to go x equals negative 1 times 0 squared. That's going to be negative 1 times 0, which is going to be 0. And that's going to give me the solution x equal to 0, y equal to 0. For the second one, I'm going to get x equals negative 1 times negative 6 squared. I'm going to square the negative 6 and get positive 36. This is going to give me x equals negative 1 times 36. That's going to give me x equal to negative 36. And that's going to give me the solution negative 36, negative 6. And for the last one, I'm going to go x equals negative 1 times 1 squared. That's going to give me x equals negative 1 times 1, which is x equal to negative 1. And as a solution, I'm going to write the x first and the y second. I'm going to write negative 1 comma 1. This is going to be my answer. I really don't want to check these. I'm going to just check them real quickly in my head if I can. 0, 0 works there. Negative 36, negative 6 works there. Negative 1, 1 works there. 0, 0 works there. Negative 1, which is negative 1. Oops, 1 minus 6. That works there. The only solution I haven't checked in my head is that one in the bottom equation. I'm going to just check this one in the bottom equation by plugging in negative 36 for y. So I'm going to check this one in that equation by going negative 36 cubed, plugging negative 36 in for y, minus 5 times negative 6 minus, oh, messed up here, backwards, can't even check that. Plugging negative 6 in for y, so I'm going to go to check, I better do this on another sheet of paper. This is dumb to try to jam stuff in. So I'm going to try to check in this equation this solution. X equal to negative 36, y equal to negative 6. So y equal to negative 6, I'm going to go negative 6 cubed. X equal to negative 36, 5 times minus 36, minus 6y, 6 times negative 6. That has to be 0. That I couldn't check in my head. I just wanted to save some time and not do every single checking, but that checking was monstrous. So let me make sure this works. I hit enter, it better give me a 0, which it did. Let me get you started on number 5, and maybe I won't finish it, but I'll get you a good start, and you can hopefully finish it up. Because I'm worried number 5 is just a little bit different than 6, and maybe my doing 6 won't get you far enough. I won't go all the way to the end, but I'll get you a good start. So on number 5, I suggested taking the top equation and solving it for y. The top equation says x squared plus y equal to 0. For my first step on number 5, I'd probably minus x squared from both sides and get y equal to negative x squared. And then I'm going to substitute right there y equal to negative x squared. So in the bottom equation, there's my step 1. Moving on to my step 2, I'm going to write the bottom equation with an 8x squared minus a 4x, and then minus a negative x squared equals to 0, changing that y to a negative x squared, leaving the minus in front of it. I have a double negative there, so this is going to give me 8x squared minus 4x plus x squared equal to 0. This is really plus 1x squared. I'm going to combine these. 8x squared plus 1x squared is 9x squared. So I'm going to get 9x squared minus 4x equals to 0. Factor out a common factor of an x. You get x times 9x minus 4 equal to 0, and you get an ugly fraction answer. You'll go x equal to 0, 9x minus 4 equal to 0. For the 9x minus 4, you're going to add 4 to both sides and divide by 9. This is going to give you x equal to 4 over 9. Then you'll have to figure out what y is by using y equals to negative 1 times x squared. So you're going to take this x and plug it into there, and you're going to take that x and plug it into there. That should take you all the way. I'm going to just double check my work real quickly here to make sure I don't see a mistake just glaring at me. Y equals negative x squared, boom, boom, boom. That's 9x squared minus 4x. X times 9. Yeah, feels good. So you should be able to finish that up now. The next two problems are really nice because in the next two problems, 7, your problem 7 and my problem 8, both equations are solved for y. So it doesn't matter what equation I'm going to pick. I'm going to pick the top equation and solve for y. That's done already for me. It's done already for you. And now I'm going to substitute into the bottom equation. So there's nothing to do on the first step because there's an equation that has a letter solved for. In fact, both equations do. So what I'm going to do, I took my top equation and used the fact that it was solved for y. I'm going to change the y in the bottom equation to what y is equal to in the top equation. So I'm going to replace that y with that x cubed minus 3x squared plus 4. Because there's an exponent, I need to get this set equal to 0. So I'm going to add 2x and minus 4 from both sides. When I did this, I shoved the 2x in, but didn't really write it under anything. The 2x has a different exponent than the other x terms, so it can't be combined with the other x terms, but the numbers are going to cancel because those are opposites. So I'm forcing my right side to come out 0, and my left side's going to have x cubed minus 3x squared plus 2x. I'm going to solve this by factoring. It should work similarly for you in that your factoring is going to be 2 steps. First step's going to be a common factor. I'm going to pull out my common factor of an x. And then I'm going to factor what's left in the parentheses. And now I'm going to set each factor equal to 0. I'll get x equal to 0, x equal to 1, and x equal to 2. For each x, I need a y, and it's a heck of a lot easier to use the bottom equation than it is the top. So on this step, I'm going to use that to solve for y. I don't have to use that. I could use the top equation, but that bottom one seems a heck of a lot easier. So I'm going to use y equals negative 2x plus 4 for each of these x's. So for the first x, I'm going to go y equals negative 2 times 0 plus 4. That's going to give me y equal to 4. And that's going to give me a solution of 0, 4. For the next number 1, I'm going to get y equals negative 2 times 1 plus 4. That's going to be y equals negative 2 plus 4. That's y equal to positive 2. As a solution, I write the x first, I pair it with the y, and give me the 1, 2. And the last one, for x equal to 2, I'll get y equals to negative 2 times 2 plus 4, which gives me y equals to negative 4 plus 4, which is y equal to 0. I pair the x with the y and write my solution as 2, 0. So my answer to this, or my answers, it's going to be the point 0, 0, 4, 1, 2, and 2, 0. Really, 2, 0. That works there. 8, 12 works there. 1, 2. I'm checking these in my head really quickly. Works there. 1, 5. Ooh. Let me check. 0, 4 works there. 0, 4 works there. 1, 2. 1 minus 3. Yeah, I just checked them in my head really quickly. I believe they work. Let me get you started on number 7, just in case the algebra is a little bit different. If you don't need to see me start, you don't have to watch me start. But just in case, to get started on number 7, I'm going to solve the top equation for y, which is already done. I'm going to substitute your top equation into the bottom equation. So as you do number 7, you should start off saying negative 2x squared plus 2 equals 2x to the 4th minus 4x squared plus 2. Set it equal to 0. Probably the best way to set this one equal to 0 is the plus 2x squared and minus 2 from both sides. Doing that's going to give me 0 on the left side, and on the right hand side I lined the terms up that need to be combined. These have opposite signs, same exponents, they can be combined. You subtract the numbers in front of the x's and get a minus 2x squared. These cancel here. At this point you can divide by 2 because there's a common factor that doesn't have a letter and there's an equal sign. That's going to give me 0 equals x to the 4th minus x squared. I can pull out a common factor of x squared. And I can factor what's left in the parentheses. That should get you going. This is going to give you x equal to 0, x equal to negative 1, and x equal to 1 for the x's, and then for each x you need to get a y. So again, that's just the start of number 7. It's not the finish, but just in case you couldn't get going. I think on the next page let me do my number 10. On the next page I'll do your number 11. For you, I would probably start yours. For you, I might solve the top for y. If you did that, you'd minus 3x from both sides. You'd get y equals minus 3x minus 4. And so in your problem 9, you're going to change that y to minus 3x minus 4. You're going to go x squared plus minus 3x minus 4 equals to 0. I put the y in a parentheses. I'm not sure why I did that. And when I drop the parentheses, this gives me x squared plus negative 3x plus negative 4. You can write that as x squared minus 3x minus 4 rather than saying plus a negative 3x, which would look kind of funny. So that's how I probably start number 9. For number 10, I'm going to solve my top for x to get started. The top is x minus 2y equal to 1. I'm going to add 2y to both sides and get x equals 2y plus 1. And now I'm going to substitute to the bottom. Very specifically, I'm going to change this x to that 2y plus 1. So I'm going to go 3 times 2y plus 1 minus y squared equals to 8. I have a squared, so I need to get it set equal to 0. And I'm going to wind up getting the 0 on the left side. Let me clear this parentheses and get 6y plus 3 minus y squared equals to 8. I'm squeezing the 8 way over because I know what I'm going to do on the next step. I could minus 8 from both sides, but that's going to mess me up because I don't like negative y squareds. So I'm going to get the 0 on the left-hand side by adding y squared, minusing 6y, and minusing 3 from both sides. The reason I tucked the 8 way over is because I wanted to have the y squared term first and the y to the first power second. So on the left-hand side, I canceled everything by doing the opposite. And on the right-hand side, I kept the plus y squared, the minus 6y, and the minus 3 that I have on the left side. So I did the same thing. This is splitting the equal sign right here. And I wrote them in a nice order. Force everything on the left side to cancel. On the right side, I'm going to get y squared minus 6y, and then 8 minus 3 is positive 5. And that's going to factor. I'm going to get 0 equals to y minus 1 times y minus 5. Hopefully your factoring skills haven't completely left you. I'm going to go y minus 1 equal to 0, y minus 5 equal to 0. I'm going to get y equal to 1 and y equal to 5. Now I'm going to solve for and get a corresponding x using x equals 2y plus 1. So for each of these y's, I'm going to get an x. I'm going to use x equals 2y plus 1 as my last step. For the first y, I'm going to plug in 1 and get x equals 2 times 1 plus 1. That's going to be x equal to 2 plus 1, which is 3. I'm going to pair these as an answer. In my answer, I'm going to pair x equal to 3 with y equal to 1. And then for the 5, I'm going to get x equal to 2 times 5 plus 1. So it's going to give me x equal to 10 plus 1, which is going to give me x equal to 11. That's going to give me 11, 5. Let me just check this one all the way out just to show you that you can check these. So if I wanted to check, first I'm going to use the equation x minus 2y equal to 1. Then I'm going to use the equation 3x minus y squared equal to 8. For the 3, 1 solution, we do that in a different color just to make it stand out. I'd go 3 minus 2 times 1 equal to 1. That would give me 3 minus 2 equal to 1 and 1 equal to 1, so it checks there. In the bottom equation, I'd go 3 for x, so 3 times 3 minus 1 squared equals to 8. So this is 9 minus 1 equal to 8, which gives me 8 equal to 8, so it checks there. And then for the 11, 5, into the top equation, I go 11 minus 2 times 5 equal to 1. That's 11 minus 10 equal to 1, which is 1 equal to 1. And then in the bottom equation, 3 times 11 for x minus 5 squared for y equals to 8. This is going to be 33 minus 25 equals to 8. That will give me 8 equal to 8. That's the proper thing to do when you finish these problems up. You should probably check every one on a test just to make sure your answers are right. You have to take each answer, plug it into both equations. An answer is correct only if you get a true statement for every single substitution. So give number 9 a finish, and I think I'm on the next page. I'm going to do 11. I'll never do 12. No, that's okay. I'm trying to, look at the ahead to see which problems are dissimilar. So let me do number 11, and I'm not going to do 12. So for number 11, probably the best thing to do for step 1 is solve the bottom for y. For x, should I say. I could solve the top for y by just adding y to both sides. That would be equally good. So if you worked ahead and solved the top for y as opposed to solving the bottom for x, there's no problem with that. So I'm going to take my bottom equation, x minus y equal to 0, add y to both sides, and get x equal to y. And now I'm going to step 2, substitute into the top. And very specifically, what I'm going to substitute is I'm going to replace the x equal to y, and kind of doesn't matter which one I substitute, but I'm going to change this x to a y, and I'm going to write that as y squared minus y equal to 0. I just changed that x to a y, and now I'm going to solve by factoring. I'm going to pull out a common factor of a y. I'm going to get y times y minus 1 equal to 0. So it's going to give me y equal to 0, y minus 1 equal to 0. For my answers for y's, I'm going to get y equal to 0 and y equal to 1. Lastly, I go to my step 3. This time I'm going to solve for x, and I'm going to use x equal to y because that's a beautiful thing to use. And for the first one, I'm going to plug 0 in for y because I have y equal to 0. I'll get x equal to 0. That will give me the solution 0, 0. And then for the next one, I'm going to plug in into x equal to y. I'm going to plug in 1 for y. I'll get x equal to 1. That will give me the solution 1, 1. My answer for number 11 is 0, 0, and 1, 1. I check those in my head rather than physically checking those. But if you want to check those, what you would do for checking, you take the top equation, which is x. If I want to check, I'd take the top equation, x squared minus y equal to 0, and the bottom equation, x minus y equal to 0, and check my solutions. My solutions are 0, 0, and 1, 1. So to check 0, 0, I'd have to go, is 0 squared minus 0 equal to 0? This would give me 0 minus 0 equal to 0, which gives me 0 equal to 0. And then the other solution is 1, 1. I'll check that in a second. And this equation for the 0, 0, you just go 0 minus 0 equal to 0 and get 0 equal to 0. It works there. For the 1, 1 solution, I'd go 1 squared minus 1 equal to 0, which is 1 minus 1 equal to 0, which gives me 0 equal to 0. And for the 1, 1 solution here, 1 minus 1 equal to 0 gives you 0 equal to 0. The checking is optional, but you really should do it if you have the desire and the time. All right. All right, probably a hiccup in the video because I kind of didn't like my problem 14, so I changed my problem 14 to look really similar to your problem 13, so they should solve the same way. Step 1 is basically done. I'm going to say I'm going to solve the top equation for y. It's already done. So in step 2, I'm going to substitute my top equation into my bottom equation. So step 1, now on to step 2, I'm going to substitute negative x in for the y in the bottom equation. Because I have exponents, I need to get this set equal to 0. I should really think of this as a negative 1x. It'll help my math here. I'm going to add 1x to both sides. This is going to give me 0 equals to x cubed plus 5x squared plus 4x. I'm going to solve this by factoring. I'm going to pull out a common factor of an x first. And then I'm going to factor what's left in the parentheses. Now I'm going to set each factor equal to 0. And I'm going to get 3 answers. X equal to 0, x equal to negative 1, and x equal to negative 4. Lastly, I need to pair my answers up. So now, pair my answers, because my answers need to be points. And I'm going to use y equal to negative x, and better yet, maybe y equal to negative 1x to do that. So for the first one, I'm going to go y equals negative 1 times 0. That's going to give me y equal to 0. So I'm going to pair x equal to 0 with y equal to 0. The middle one, I'm going to get y equals negative 1 times x, which is negative 1. It's going to give me y equal to 1. So I'm going to pair x equal to negative 1 with y equal to 1. And lastly, I get x equal to negative 4. I'm going to get y equals to negative 1 times negative 4, which will give me y equal to 4. That's going to give me the solution of x equal to negative 4, y equal to 4. So my answer for problem 14 should have the 3 points, 0, 0, negative 1, positive 1, negative 4, positive 4. Your work for 13 should be exactly the same, at least really close to the same. I feel like my 16 is easier than your 15, so I'm going to do your 15 as opposed to 16. So I'm going to, for 15, to get started, if you want to pause the video and do it ahead of me, that would be great. But I'm going to solve the top for x to get started. So because it's a lot easier to solve the top for x than it is any other combination. So to do this, I have to add 7y and minus 6 from both sides. This is going to give me x on the left side, and on the right side, I'm going to write the 7y first, and 12y minus 6 I'm going to write as a plus 6. So I'm going to write this as 7y, which is that 7y, and then plus 6. Wow. And now I'm going to substitute. Into the bottom. So into the bottom, for the x, I'm going to put 7y plus 6. So I'm going to put, they get some nasty numbers as near as I can tell. I'm going to go 7y plus 6 squared minus, I'm going to emphasize 1y squared equals to 36. And I'm going to clear the parentheses by foiling. So I'm going to set it up so I actually can do that foiling. So firsts will give me 49y squared. Outers will give me plus 42y. Inners will give me plus 42y. Last will give me a plus 36. Now I'm going to combine like terms on the left-hand side. And very specifically, I'm going to take this 49y squared and that minus 1y squared and make a 48y squared. And then this 42y and that 42y I'm going to write as a plus an 84y. And just to save a little room, I'm going to minus 36 from both sides as well on this step. which is going to cause the numbers to cancel out on both sides, will cause me to have a 0 on the right side. There's definitely a numerical common factor. I don't know what it is. I think it's 4. 48 divided by 4 is 12. 84 divided by 4 is 21. It's actually 12. 48 divided by 12 is 4. 84 divided by 12 is 7. I'm going to divide by 4, by 12. I forgot to write the y here. It's supposed to be 48y squared. I divide by 12, divide by 12, divide by 12. When a problem has an equal sign, you can divide out a numerical common factor. And this is going to give me 4y squared plus 7y equals to 0. Pull out my common factor of a y. I get y times 4y plus 7 equals to 0. Yuck. Another sheet of paper. I'm wearing out, so I got to imagine you've got to be close to worn out too. This is going to give me y equal to 0, 4y plus 7 equal to 0. For the 4y plus 7, I minus 7 from both sides and get 4y equal to minus 7. Divide by 4, divide by 4, and get y equal to minus 7/4. Now I'm going to pair my answers. And I'm going to use x equals 7y plus 6. So I need to pair. I'm going to use x equals 7y plus 6. For the first y equal to 0, I'm going to get x equals 7 times 0 plus 6. That's going to give me x equal to 6. That's going to give me 6 and 0 for an answer. For the y equals to negative 7/4, I'm going to get x equals to, really, wow, 7 times negative 7/4 plus 6. I really think I have to have a mistake. I don't see that mistake, so let me just do this. X equals 7 times parentheses negative 7 divided by 4 plus 6 equals math, enter, enter. I get x equal negative 25 over 4. So this says negative 25 over 4 comma negative 7 over 4 is my other solution. So theoretically, these are my answers. Should definitely check these because I don't generally give fraction answers. So let me try to check these. I'll yank out another sheet of paper. So I need to check into two equations. I need to check into x minus 7y plus 6 equal to 12. And I need to check into x squared minus y squared equal to 36. The solutions that I came up with are 6, 0. That one doesn't worry me so much, but this negative 25 over 4, negative 7 over 4 really does worry me. So let me check them both. The first one, I'm going to go 6 minus 7 times 0 plus 6 equal to 12. This gives me 6 minus 0 plus 6 equal to 12. Gives me the 12 equal to 12. Bottom one, I go 6 squared minus 0 squared equal to 36. This gives me 36 minus 0 equal to 36, which is 36 equal to 36. This is the one I'm so worried about. So for this one, in the top equation, I go negative 25 over 4 minus 7 times negative 7 over 4 plus 6 equals to 12. Time for my calculator. Negative 25 divided by 4 minus 7 parentheses negative 7 divided by 4 plus 6. It has to say 12 when I hit enter. Whew, thank gosh. Works in the top one, down to the bottom one. For the bottom one, I have to go negative 25 over 4 squared minus negative 7 over 4 squared, and that has to equal to 36. Calculator time again. First one, parentheses, negative 25 divided by 4 squared minus negative 7 divided by 4 squared. When I hit enter, it has to give me 36, which it does. It's just a really surprising answer. Usually I don't like to have fraction answers if I could help them. For whatever reason, I got the horrible fraction answers there, and that just is what it is. So the answers are what they are for problem 15. Let's just do one more problem. Let me analyze what we have left to do. 17 and 18 feel a lot alike, so let's not even ever look at 19 and 20. You can try 19 if you like. If I was doing 19, I'd solve the top equation for y and substitute it into the bottom, but let's not worry. Let's just get one more and I'll feel good about the section. And let me do your 17. So we're going to stop at problem 17 and 18. There's a problem 19 and 20 which I've thrown out a few seconds ago. I decided to do number 17 as opposed to 18 because I thought it would help you, and this will be my 4th time doing number 17. I keep making a mistake, and it's not that hard, but I'm tired, and doing math when you're tired apparently is not a good idea. So let me see if I can get it done this time. So to start number 17, probably the very best thing to do on number 17 is first solve the top equation for y, for x. So I'm going to take this equation, x minus 7y plus 6 equals to negative 4. I'm going to solve it for x. I'm going to add 7y to both sides and minus 6 from both sides. When I do this, the left side's going to give me the x. The right side, I'm going to have the 7y. The numbers have the same sign. I'll add them and keep them negative. And now I'm going to substitute into the bottom equation. And so I'm going to substitute into the bottom. So I'm going to go 7y minus 10 squared plus y squared equals to 20. Should say that that's really a 1y squared. And now I'm going to do 7y minus 10 squared by writing it without the square. Now I'm going to clear my parentheses. FOIL, firsts are 49y squared. Outers are minus 70y. Inners are minus 70y. Lasts are plus 100. Now I'm going to do a couple things. I'm going to minus 20 from both sides to get the 0 that I'm going to need to have in this problem, which is going to make this number be a plus 80 and the right hand side have a 0. I'm also going to combine the 49y squared and 1y squared and get 50y squared. And I'm going to combine the minus 70y and minus 70y and get a minus 140y. No way I want to solve that. There's an equal sign and a numerical common factor. I'm going to divide every single number by 10 to make the problem a little more manageable. This is going to give me 5y squared minus 14y plus 8 equal to 0. I tried to be nice and do the quadratic formula for you to solve this, but quadratic formula for me is way harder than factoring, unfortunately, and I made so many mistakes. My mistakes were all in the quadratic formula. This can be solved by the quadratic formula. If you're comfortable with the quadratic formula, you're so welcome to use it. I'm not going to attempt a third failure on the quadratic formula, and I'm going to solve this by factoring. So it's bottoms up factoring, I suppose. So to solve this, I'm going to bottoms up factor. So I'm going to multiply by 5 and rewrite, meaning that and that I'm going to multiply, which is going to give me y squared minus 14y plus 40. And then I'm going to factor this, which is going to be y minus 10 times y minus 4. And then I'm going to divide by 5, reduce, and bottoms up. So I'm going to go y minus 10 over 5 and y minus 4 over 5. The y minus 10 over 5 is going to give me a y minus 2. The other one I'm going to bottoms up and get a 5y minus 4. That's what I'm going to write in place of 5y squared minus 14y plus 8. So I'm going to change this to be y minus 2 times 5y minus 4 equals to 0. Now I'm going to set each of those factors equal to 0. I'm going to go y minus 2 equal to 0 and get y equal to 2. And then 5y minus 4 equal to 0. I'll add 4 to both sides and get 5y equal to 4. And then I'll divide both sides by 5 and get y equal to 4/5. Done with step 2. Need to work on getting x's, and I'm going to use my x equal to 7y minus 10. So now I need to solve for the x. I'm going to use x equals 7y minus 10. For the first y, I'm going to get x equals 7 times 2 minus 10, which is 14 minus 10, which is 4. That's going to give 4 comma 2. And then for the ugly one, I'm going to get x equals to 7 times 4/5 minus 10, which is 7 times 4 divided by 5 minus 10. Math, enter, enter, and I get x equal negative 22 over 5. It's so scary because these numbers look so similar to my wrong answers. I'm going to check these, because if I don't check these, I'll probably be writing down something that's not right. So those, I think, are my answers. I hope these are my answers to this problem 17. But I don't know my answers are right until I check. So I'm going to check by pulling out a new sheet of paper, and I'm going to write down the two equations I need to contend with. I need to contend with x minus 7y plus 6 equal to negative 4, and I need to worry about x squared plus y squared equal to 20, and I have to check for 2, and I need to check negative 22 over 5, comma 4 over 5, and quite honestly, there's where I'm really concerned. So for the first checking, I'm going to put in 4 for x and 2 for y. I go 4 minus 7 times 2 plus 6. That needs to be negative 4. I'm just going to do it by pressing buttons. So 4 minus 7 times 2 plus 6. I better see negative 4, which I did. Works there. And then in the bottom one, I'm going to go 4 squared plus 2 squared, and that better be 20. That one I can do. This is 16 plus 4 equal to 20. That's not what I'm worried about. What I'm worried about is this horrible solution over here. So let me try this one by going negative 22 over 5 minus 7 times 4 over 5 plus 6. That has to be negative 4. So negative 22 divided by 5 minus 7 times 4 divided by 5 plus 6. So 3 times, or a few times now, when I've hit enter, I haven't seen negative 4. If I see negative 4, it's right. If I don't, I've made another mistake. Finally, that works. Now I'm moving on to the bottom one, and I'm going to see if negative 22 over 5 squared plus 4 over 5 squared equals to 20. Last checking, last end of this video. So negative 22 divided by 5 squared plus parentheses 4 divided by 5 squared. It better say 20 when I hit enter, because the right side is 20, which it does. So I know the answers for problem 17 that I flashed up on this page are finally correct. There is a problem 19. Just go ahead and skip it. I think we've done way more than enough of these. It didn't feel like it was going to take so long to do this section, but it did. So I think stopping at 17 is a good place to go. And stop.